Hey everyone, here we are at it again, another exciting release for HyperStudy. Thank you all for attending and showing interest in upcoming features and enhancements in this release. These are the main categories that all our improvements fall under: connections, methods, and post-processing and visualization, reports, and customization. The first category is connections. Regarding our Excel connection, there has been a quite number of our requests, especially this year from the field, to save the spreadsheet with updated parameters in each run directory. The most common use case is the final spreadsheet file being fed into a following process as an input file, such as like a Python process or any other like scripted process. So what we did was we implemented the save command or the save option at the import stage. After picking input and output variables, for those who are familiar with the connection, the user will be prompted whether they want to save a copy of the session or not. The save command is going to be stored, as you can see in the HStudy file, as a metadata. So I can just quickly jump into HyperStudy's GUI and demo the connection and the feature. Here I have the one spreadsheet model, a very simple one. I'm going to go import the variables. Okay, here I'm going to go select the input variables. I don't have any more input variables than output now. The last one is going to be output. And as soon as I'm done with my variable selections, as I mentioned, the user will be prompted with a save operation a window. So here, depending on your the command, it's going to be stored in the XML, whether it's going to be a true or false like statement. So when you say yes, I'm just going to quickly run this one. When you run it, if you go to the run directory, you'll see that there's a spreadsheet file with the updated parameters. And as I mentioned, if you look at the XML file, the save copy in the option true will be stored in the XML file as a metadata. Okay, just going to go back to my presentation. The second category we have improvements, enhancements is the methods. We have two enhancements in this category and this one. The first one is in the result area. We are introducing a new extraction tool called regex or regex, whichever you pronounce it. Using regular expressions, one can pull out data from a human readable file. The new tool is going to coexist with our long trusted ASCII extractor. It's not going to replace it. The ASCII extractor stays. But unlike ASCII one, the regex tool is insensitive to location of the variable. So imagine you have an output, OptiStruct output file in which you're reading volume or mass values. And if tomorrow OS10 decides to change the location of where the volume or the mass is written, the ASCII extractor will naturally fail due to its dependency on the reference point and character spacing. So I'm going to demo this as well with some, few examples. Regex. So here I have this text file. This text file embarks different data types, the numerical ones, real numbers, and strings, and etc. It's by the way, for those who are familiar with the regex, our implementation is based on the ECMA script engine, or flavor they call it, which is also used by languages like JavaScript and C++. But if you really want to get familiar with those regular expressions, there are tons of tutorials and practice websites online. So I'm going to start with this a variable here. So it's pretty simple. I'm going to go start with the a equals, and then using parentheses, I'm going to go point star, and it's going to capture all the variables in the text file and store them in a list here in the preview area. I can read another one. For example, I can go read the G variable. and that will also like going to capture the characters after the equal sign. When you use the capture, and we also have the capture and the match option. When you say match, for example, it's going to capture the entire line here. But if you specify the words, for example, it's going to get the string itself. But if you do none, it's going to include everything in there, just all these characters like equal sign, etc., or curly braces, whatever you have. For example, I can go read the D variable. I go back to capture. Capture is very specific to what you have in the parentheses here. So when you do the capture, and it will capture these strings here, 1 and 2. You might have like multiple ones, so it will just put everything into a list here. But you can go specifically with the words as well. But when you go to, for example, real numbers, there's no number in there, so it's not gonna capture anything. Yeah. So this is what we have. Like I said, it's gonna be it's gonna coexist with the ASCII extractor. But for those who wants to switch to a regex, definitely if they need help, just let me know. And like I said, also you have tons of tutorials online to get familiar with it. Okay. My next point will be in methods sampling fit for vector data. So if you guys recalled in the previous release, we introduced the vector fit, but it was limited to existing historical data. So basically, we're just working out of the fit existing data, the approach. Now we're, the building vector fit is also available in sampling fit approach. So like the scalar fit, you just define your target cross validation R-square value and just let it run. I'm going to quickly show the from the GUI. So here in sampling fit, in the fit specifications area, not only we have the scalar, we also have the vector type of fit or vector data supported. For this release, we only support, as you know, or some of you might know, that only the LSR, but we can extend it to RBF and MLSM soon. But in any case, so you can go check the change your R-square history throughout the whole a cycle or the whole iteration history. That's about it for the sampling fit regarding vector models. Okay, we have the third category, post-processing and visualization. We have quite a bit of improvement in this area. The first one, I'll start with the confidence intervals. This really the born out of the discussions when we're introducing the vector fits. Why not we show the confidence intervals? It's a very common type of visualization, aid for for those who use predictor models. And first of all, I like to get into for those who don't know what confidence intervals are. They're used for measuring the degree of uncertainty in predictor model. For example, here in this image, we have two different confidence interval plots for both scalar and vector models. In the left one here, I'm predicting the first frequency. In the second one here, it's a vector prediction, and I'm predicting the first 6 modes of the system. In the left one here for the whole design range of dimension A, the confidence level, as you can see, it's sort of getting the upper and lower limits for the confidence interval is getting larger toward the end of it, toward the upper limit of the dimension A. And here, for example, in this vector fit, by looking at the data here or the plot, I can see that my confidence in this predictor is less reliable around the 6th mode of the system. So everywhere else like seems to be pretty good. I mean, even this might have been good, but just like relatively, it's doing worse comparing to the other modes. Let me quickly show in HyperStudy. I'm going to use the same model. So in this area, in trade-off area, we have. I'm sorry, I got to reopen this. Okay. So in this three-dot menu here, we introduced the interval options here. These options are coming from a preference study MVW file, which is sitting in the main installation directory, Altair installation directory. So I'm just going to go show it in the Notepad++. Here we introduced a new sort of category begin fit metrics option. So selectively you can just define your own type of confidence interval. You can use a different percentage. You can use a different color. For the colors, for example, we're using the HTML color code, such and such. And also you can remove all these confidence intervals using this command here, just putting a star. I mean the notice here, so it's really hard to miss. So using this preference study file, you can define your own confidence interval setup with different labeling, obviously, if you're interested in. So here I'm going to go, activate the 95%. So I'm just going to move that to top left here as well. Okay. So I'm going to go change sliders a little bit, see the the confidence interval for a different set of variables or combinations. Yes, that's about it regarding the confidence intervals. Going back to my presentation. Okay, another area that we're coming up with improvements or as a new feature, I would say, is ranking input variables. So historically Pareto charts, they've been leveraged for identifying important parameters for each individual response. Once the most important or relevant parameters are defined, it is strongly recommended to reduce the dimensionality for the next subsequent approach. And we know that, we're aware that we're familiar with that the inclusion of unnecessary dimensions variables causes degradation in accuracy. So for that reason, we came up with this variable ranking based on their global contribution. And the ranking also can be used to auto-create a new DOE with only relevant variables being active. That one, also go back to GUI quickly. Here, I'm going to be demoing it on a long trusted or our most user-friendly example of beverage can. Here, I have all the full set of design variables here. And the responses, I'm going to limit it to 4 of them because of the graphical area. It's going to be a lot easier to show. Here in post-processing in Pareto plot, you'll see the ranked input, sub tab here. So this area, what we show here, is very sensitive to what's being showed here in the graphical area, which is tied to this the number of factors being displayed. So if I just reduce that one, for example, to 4, only the visible parameters will be populated in this table here. And if you look at the contribution column here, it's all based on the percentage. So how we calculate it is we have 4 responses, and if you look at each the response and, for example, the diameter is and their contributions, we just sum all the diameters come from the contribution and divide it by 4. I mean, the number of the responses. So we just average it out. And based on this one, if you look at it, the diameter is still the top contributing a factor here or input variable, and then height and etc. And the point is when you have interactions, how we calculate, like, the contribution of, for example, here, when you have the interactions of diameter with some other like variables, basically we just take the contribution percentage of this one and just split it like between the two 50-50, and then average it out again, as I explained previously for individual ones. And this is how we come up with the contribution values. And then once we have the contributions, user can selectively pick the variables they're interested in, and then out of this like selection you can create a DOE, which is going to have only those selected parameters active in the definition area. So in return, this is going to this is going to reduce the dimensionality, and hence it's going to help with the the accuracy or the data sampling, like a scheme, whichever method you're using it for. And down the stream, if you're interested in fit, obviously, or optimization, that's going to help too, using the same set of variables. Okay, that's all I can talk about the Pareto ranking. Okay, another development, or a new introduction, is the pedigree information for each evaluation. So for each round, now HyperStudy is reporting the origin of the IDs and the source approach. And these two extra pieces of information can be really handy in certain scenarios. For example, you can filter the data based on their source approach, or you can just sort them out based on their origin source approach. Or when some runs are filtered, further down at the post-processing step, the original runs are still being kept, so they are not lost. And so to show the value of this, the information of this metadata columns, I'm going to go create a simple beverage can here. I don't have any specific model for this one. I'm going to go create one DOE, and that DOE will have, say, 5 runs. Okay. I'm going to go create the next DOE, DOE2. Okay. Here, I'm going to include the data coming from the first DOE, right? And I'll create another 5. Okay. When I run this one, in the evaluation task area, you'll see the origin or the source approach and the original, index of the each evaluation point. So I can sort this column. Now I can filter this column using their own source approach, whatever the strings in there, or I can just sort it out like this one here, set the order. Or what happens, for example, if I exclude this number 6 and the number 9 from the post-processing area. If you look at it, for example, in scatter data, we have this show evaluation index. The previous behavior would be when you exclude number 9 from the post-processing area, so the 10th number automatically sorted out to be the number or the run number or run ID 9. We don't want that behavior because we want to keep their original ID. And in case, for example, you might want to go into that folder using some custom reports option, whatever, and pull some results from there. And also, you might be familiar or with the design variable of that or set of design variables for the number 10, and you don't want to confuse it with the number 9 here, right? So here, if you look at it, so the run number ID 9 is not here anymore, and we just kept the original ID for the 10th evaluation. So similar to what we see here in the summary table. And later we will use this the metadata in some post-processing areas, which is going to be coming in probably in the next release. For example, you can use the bubble plots and one of the dimensions could be like the approach type here. Okay, let me go back to my presentation. Another one is visualizing curve differences. For those who are familiar, we've been using area data source tool to perform curve matching studies such as material calibration, frequency match, and etc. But however, it was excluded from the post-processing stage. Now with the introduction of the new area tab, curve differences can now be visualized for each run point. If I open curve matching example here, for example, it's tucked away, hidden here. You can just go ahead and activate the area tab. When you activate it, you'll see the area data sources like tab. You might have like multiple of them, and the summary here, which is like exactly the mirror of the summary table here. Okay, and I could pick like single or multiple one and do comparisons. Supports the multiple window. So basically, like in optimization, you get optimum runs or whatever, but it will be also useful to look at some of the maybe a violate runs, but which is not far away from the thresholds and etc. But you might be still interested in that design variable set. It might be more suitable toward your whatever design criteria. So it will be all good to investigate through this like a new area tab here. Okay. The last one is reports and customization. I'm not going to domain anything for this, like the particular category, but I'm gonna go simply over what we have. Now we have the vector fits, and we can export all these vector fits in the FMI like container. So basically, you can take this FMU and just as a mobile predictive model, and just plug in anywhere in any platform you're interested in. For example, in here, I just put it into activate like a diagram, and using the vector scope, I can just look at the in this particular example, I'm looking at the first 6 modes of the whole system. So you can plot it this way, or using as a code simulation, the engine. Another one is for those who are interested in using custom vector fit models. You can use our Python API now to register your own vector fit models. And thank you so much.